Hey friends, in this video we are going to understand the basic fundamentals of the light wave travel through the fiber cable. Before moving into the actual topic, we have to understand the basics on how the light wave travels between different mediums. Optical density is a very important parameter to understand how the light wave transmission works across different mediums. Optical density is related to transmission of light wave. It is measurement of refractivity of the medium through which the light wave moves, or how much light speed would change when the medium of its travel changes. As shown here, refractivity in simple words is the tendency of the light to bend rather than going straight when the medium changes. It also leads to change in the speed of the light signal when the medium changes. Different mediums have different optical densities. So when a light wave crosses from one medium to another, it faces different optical density, and accordingly the speed of the light increases or decreases as per the change in the optical density value. The speed of the light depends on the optical density of the medium. More denser the medium, slower would be the speed and higher would be the refractivity. Water is more denser than air, which means light will travel faster in air compared to water. Vacuum is taken as a reference having refractive index value of 1, where the light travels at a speed of 300,000 km per second. Few other materials are also listed here along with their refractive index values. The value indicates the number of times the speed of light would slow down in that particular medium compared to the vacuum. For example, the speed of light would be 1.33 times slower in water as compared to its speed in vacuum. The other significant part is the angle at which the light enters into the second medium. If the light enters at 90 degrees at the boundary of the two mediums, it would go straight through without any bending, although the speed would change basis the optical density of the medium as we just understood. And when the light ray hits the boundary between the two mediums at an angle other than 90 degrees, it doesn't continue at the same angle in the other medium. It rather bends towards the medium which has higher optical density. This bending of light is called refraction. The animation here would make our learnings more clearer. The animation here shows the behavior of a round stone while entering from air medium into water medium. From the learning so far, we would be able to understand this simple animation. Let us map our learnings to fiber cable. What keeps the light to stay inside the core of the fiber without leaking outside? Well, let us see what makes the fiber cable first. Fiber cable consists of three concentric basic parts, namely core, cladding, and outer protective coating. Core, which is made of silica glass, is the part where the light signal travels. The core is surrounded by another silica glass tube called cladding. The cladding is covered with protective coating which prevents it from easy breaks and allow flexibility of bending of the fiber cable. To keep the light signal stay inside the core, the refractive index or optical density of the core is kept higher than the cladding. Let us understand how it works. When light from the laser source entering into the core is incident at the boundary of core and cladding at an angle A1, the light enters into the cladding and gets bent inside the cladding towards the core surface. The bending happens due to different refractive index of core and cladding. The bending happens towards the core as its refractive index is higher than the cladding, as we have understood earlier. and it is very clearly seen in the animation here. The angle of bending or refraction can be seen as R1. Now the angle of incidence is increased from A1, and it can be seen that at a particular angle AC, the bending of the light happens exactly at 90 degrees, thereby moving straight along the boundary between the core and the cladding. This angle of incidence, where the bending of light happens at exactly 90 degrees, is called critical angle. In simple words, critical angle is the incident angle at which the refracted signal is bent at 90 degrees. Now, when the angle of incidence is further increased above of critical angle, the light ray bends so much that it stays inside the core, thereby resulting in 100% reflection and 0 refraction. This implies that the light from the laser source must be incident into the core and cladding surface at an angle greater than critical angle. This would result in total internal reflection and keep the light inside the core, thereby 0 leakage into the cladding. To summarize, in fiber optics, the light signal shall be incident at more than the critical angle, and the refractive index of the core must be higher than cladding. I hope that the explanation here would have helped you understand the light transmission inside the fiber cable and what keeps it inside the core without leaking into the cladding. If you have liked the video, please do not forget to hit the like button. Please do subscribe my channel on YouTube at the link shown. You can also view these videos on my Facebook page at School of Telecommunications. Kindly share the video in your respective circles where you feel that this might help the reviewer. Thanks for watching. Look forward for continued support. Stay blessed.